Hi, hello and welcome. My name is Tim Pennell, and I'm a Director of Product Line Management in Juniper's Automated WAN Solutions Group, responsible for end-to-end solutions and WAN deployment use cases for all our customer segments globally. So that's spanning service provider WAN, cloud WAN, and enterprise WAN. So today, I'm going to share a short presentation that explains at a high level our approach to scaling of nodes in your WAN in a way that provides you with an optimum yet flexible solution, both for today and into the future. You will have seen this slide before in other sessions, most likely at this virtual summit. It's essentially summarizing our approach to SP transformation. So Juniper is bringing cloud, 5G, and AI solutions to life with cloud-first platforms, distributed edge clouds, massively scalable IP fabric with network slicing. So this is the bit that we're going to talk about today. So this includes the entire X-Hall portfolio with MX, ACX, PTX, everything from 25 gig to 400 gig transport, network slicing, segment routing, low latency and hybrid timing, also support for flexible architectures and interface diversity that's agnostic to the various RAN models from classic cloud to open RAN. Then on top, of course, we have the automated operations and finally connected security. So all of these things together is driving essentially a shift in architecture, operational economics, and services to enable SP business transformation. So if we look at some of today's common core designs, they each have pros and cons. So the classic single plane core design uses a single IGP and typically two modular chassis. Can be a modular chassis or a fixed chassis in a smaller node, or even a multi-chassis approach. But essentially, two modular chassis for redundancy is typical. And its benefits are really simplicity with a single IGP, optimal routing, lowest cost up to the scale-up limits of the single chassis. However, as drawbacks, you've got availability drawbacks in terms of blast radius, where, of course, with two routers, essentially you're losing half your capacity if one of those fails. And upgrade costs. So once you hit the capacity of that particular modular router, you then got a major upgrade cost in either going to a new platform or replacing next generation line cards. So the dual plane core, as a comparison, it improves on availability with link and node redundancy on separate planes, with each plane representing a network service transport domain. At scale, with more routers sharing the capacity. However, routing and convergence are suboptimal with these designs, and you're adding complexity and cost. And finally, a multi-planar core, returning to our single IGP once more, but using shunt links between planes to improve routing convergence. So it improves some of the issues of the dual plane core, but the drawbacks of cost still remain. So the question we have to ask ourselves is, what is going to be our optimal approach to core design moving forwards? So we have an increasing number of changes, both known and unknown, in relation to the future core network demands. So on top of the general need for a faster and more scalable network that can compete, improve your customers' experience and protect your business from threats, we also need to have a network that's flexible and agile enough to deal with these knowns and unknowns. So what are some of these knowns and unknowns? Of course, one of the knowns is that we're going to have traffic growth year over year. Of course, an unknown associated with that is yes, but by how much, for which services, and is that equal in all parts of the network or is particular parts of the network? And of course, it's more likely the latter. Other knowns are, obviously movement of traditional services for business to things like secure SD-WAN, SD-VPN services, etc. A move from a very centralized peering model that we've had in the past to more distributed peering. Similarly, centralized IT infrastructure to distributed telco clouds and databases, application diversity to low latency experiences using slicing. Those are all things that we know will happen. But then on top of that, we've got a lot of unknowns, things that are outside our control. Whether that's, if you're a service provider, new over-the-top based services, things like augmented reality, virtual reality, and what's the growth rate of those services? How's that impacting the network? regulations, things like data localization regulations or country-specific content, economies, so ARPU, growth rates, business models, private networks, how our changing economies are going to be impacting all of those things. And of course, unexpected things like natural disasters, like the pandemic issues we've had recently, all of these add uncertainty and risks to the core network along with the rest of the network moving forwards. And that's why a flexible and agile network is what we're looking to deliver. So following similar trends that we've seen in other tech industries, such as compute, for example, the shift from mainframe to server-based architectures, the WAN transition to the type of scale-out architectures that originated with cloud hyperscalers, which themselves were inspired by the earlier evolution in DC fabric designs, is not unexpected for us in the WAN. Those cloud hyperscaler principles here, included very high-scale, essentially cloth architectures, so fabrics, enhanced resilience, primarily through greater scale out and smaller blast radius. Open architectures, very important, with interchangeable components, whether from the same vendor or from different vendors. And finally, uniform and very importantly, automated operations. So Juniper's been working with cloud hyperscalers from the beginning, helping them to develop and design and deploy these types of scale-out fabric architectures. I think we're still the #1 vendor in this space with respect to cloud routing, with a market share of some 50%. The key takeaway from that is simply that our portfolio has already been well prepared to accommodate these new scale-out use cases in terms of hardware, Junos feature set, and operations. So what does a scale-out architecture look like, and how do you evolve to that? So if we start on the left-hand side, here's your traditional scale-up model. So you've typically got a modular chassis, and you will add, in a scale-up fashion, additional line cards as you need to grow capacity. Eventually, you're going through multiple generations of those line cards, and so you may have also additionally some migration to new fabrics that go along with that. But ultimately, with this architecture, whilst it's very efficient in terms of operations and adding capacity, just simply adding line cards, it reaches a limit in terms of the capacity of that single chassis. And at that point, you either have to rip and replace to another chassis, next generation chassis, or you need to put in a larger chassis. So it's a very efficient model. It's a very well-known approach. It has lowest cost up to the limits of the chassis. Then you have to go through a major architectural replacement process to scale. On the right, if we look at the full scale-out cloth architectures that some of the hyperscalers have deployed, you have a spine layer. This itself may be a multi-tier. And you have a leaf layer, and these are all interconnected, typically optically. It's very scalable. You scale out, as well as you can add additional layers to this. So higher scalability, but the downsides of this architecture, of course, is the cost. Not just CapEx cost, but also OpEx cost. Also, in terms of the architecture itself, so everything scales. So the number of links that you can see there is scaling, your IGP is scaling. So operationally, it's something that is very much driving us towards an automated system to be able to manage this. Generally, for most of our customers, except from the very largest hyperscalers, we don't need to have that much scale at this point in time. And so really the middle way that we're showing here, which we feel is the most optimum way for most people today, is you do some limited scale out. So essentially what we're saying here is rather than just having two chassis side by side for your scale up model, here you add an additional bit of scale out. So you maybe put 4 chassis and you're scaling out in this way. You may have some limited leaf for fan out of lower speed interfaces, but essentially this is a compromise scale out, if you like, that fits well with most people. And then as you evolve towards more scale out over time, you maybe add more leaf. It's a very natural evolution. So you get the benefits of the lower blast radius. It's a natural evolution from where you are today in scale up. And you have a kind of a mid-range cost, giving you a transition path from left to right as you look at that slide. So ultimately, for your next generation core, what Juniper recommends to help you become more agile as you evolve your networks and scaling with demand and enabling new service is a cloud-native open architecture based on a scale-out model, giving you the flexibility to deploy a mix of legacy and future technologies, solutions, and architectures in diverse environments without compromising on performance. We encourage close scrutiny of some competing solutions. Cloudified is not the same as cloud native, and certainly actions speak louder than words when it comes to being open. So beware closed spine leaf architectures where the fabric and leaf layer are definitely not open with regards to the interface between them. Ultimately, your architectural design choice will be driven by your business requirements, but certainly fabric-based designs delivering secure and differentiated multi-service support with network slicing and now deployable options. They're an architecture in which we continue to innovate to simplify deployment and operations with recent introductions like fabric topology isolation and flood reflectors. In conjunction with technical solutions for new core deployments, Juniper is also introducing new consumption models to complement this. Since it's already been rolled out for customers and partners, many of you will already be familiar with Juniper's Flex software licensing model, which added the flexibility of subscription and license portability to our existing perpetual licensing options. However, we're adding additional options to enable greater flexibility and agility to your network deployments while protecting your investment in Juniper software. Our automated WAN products are being enabled to operate in conjunction with our Juniper Agile licensing server, or JAL, and this enables consistent lifecycle management for all Juniper entitlements, including perpetual and subscription, intuitive task-based web portals for end customers, partners, and Juniper users, efficient and flexible license deployment and administration, with the added agility that comes from a license pool managed at a network level, rather than individual licenses permanently attached to the level of a line card or fixed system. Monitoring of the software usage also gives you visibility so you can track adoption and growth. And finally, advanced licensing models that align to your business needs. So one of the key advanced models we're introducing is pay-as-you-grow, or pay-G. We're shipping hardware now, which is delivering unprecedented capacity per slot or per system, and typically only a fraction of that capacity is what we will require on the initial deployment. So with pay-G, we license the capacity down to a port level, including also the traditional license tiers, advanced, premium, and you only need to pay therefore for the capacity and features as they are consumed. This gives you both lowest initial deployment costs and also more closely aligns future costs with your growth. So to summarize, the Juniper solutions for your core include industry-leading 100 gig and 400 gig densities across a complete and versatile PTX portfolio of fixed and modular orthogonal chassis, fixed systems supporting up to 160 100 gig ports, and modular systems with up to 144 100 gig or 36 400 gig ports per slot, or 16 slots in just 21 rack units or half a rack. It's all based on the Juniper Triton silicon. This is optimized for core and delivers not only the best densities, but also integrates into a single chip capabilities, such as MaxSec, that our competitors use external components to, so making us more power efficient if you compare apples to apples. There's no compromise on functionality and performance, so it's enabling us to deliver market-leading packet processing with fine-grained monitoring and network convergence capabilities at a scale that gives you the highest confidence in your network's operation. Triton Silicon has already delivered investment protection to our customers through many generations already, and we continue to invest in these generations of silicon moving forward with a roadmap to 28.8 terabits per slot and also for fixed systems. We continue to deliver all use cases across our automated WAN routing platforms, whether they're based on Juniper silicon or merchant silicon, from one Junos giving you operational consistency and feature velocity in addition to stability and security. Our cloud experience and leadership has helped drive our Junos feature set and automation capabilities so we can deliver best-in-class solutions for both traditional scale-up as well as the emerging scale-out architectures. Coupled with our one Junos, the universal chassis shared across the PTX family, as you see here for core, as well as our MX series for edge, our QFX for data center, delivers versatility and flexibility and helps reduce the effort and time needed for platform certification, whilst our Agile licensing enhancements also brings automated software lifecycle management, efficient and flexible network-wide license pools with optimal fine-grained consumption of capacity and functionality. Finally, we are committed to bringing you end-to-end WAN solutions that are automated and, most essentially, for your future deployment options, an open Agile architecture. With that, I'd like to close this presentation. If you'd like to understand more details, please do get in touch with us via our account representatives. Thank you, and stay safe and well.